Hi everyone. We're looking at some test question practice because historically Mill Creek students have not performed well at this. We went over measurement in class, so you know that in the standard English measurement system that we use, inches are broken up into 16ths. So I'm going to skip that one because I want to talk about three-part ratios and especially the tape diagram. So if you were in class today and you didn't understand what this meant, this is the video for you. So these tape diagrams are based on math that was developed in Singapore math, and students in Singapore visualize numbers. So like this 96 centimeter triangle, the ratio of the sides is in a 3 to 4 to 5 comparison. So 3, I'll say this is 4, and this is 5 in this ratio. That's a size comparison. So the key here is to look at this part to part to part ratio and know that altogether we have 3 plus 4 plus 5. That's 12 parts. This ratio has 12 parts to it. So I'm going to think of this way. If it has 12 parts, I can divide up this number, this tape, into 12 equal pieces. So I'll try to do it this way. There's half. There's some sixths. Divide that up into thirds. Now I'll divide this up. And my drawing doesn't look all that great, but we're going to assume that we have 12 equal parts. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 parts. So now I can use this comparison. There's 12 parts total in this three-part ratio. And what I know about this triangle is that the perimeter is 96 centimeters. So altogether, all around this triangle, it's going to be 96 centimeters. So now, I can find out the value of every equal part in the ratio. I know this 96 centimeters is broken into 12 parts. So if I take 96 and I divide it into 12 equal parts, that means every part is worth 8 centimeters. So this is 8, this is 8, this is 8, this is 8, this is also 8. All these are 8. And the reason that helps me, if I know the value of one part of this 12 part, of these 12 parts in my ratio, if I know the value of one part, I can use the ratio to calculate the sides. Because I know that the shortest side is 3 times the size of each part. And the middle side is 4 times. So I've got the 3 parts are here. So that's 8 plus 8 plus 8. That shortest side is 24. And my medium side, that's 4 parts. So that's 1, 2, 3, 4 parts. So my medium side is 32, and that makes my longest side, the one that I'm trying to find, 1, 2, 3, 4, that's 5 parts. So my longest side here is going to be 40. So this was just a way of dividing up, this tape diagram is just a way of visualizing the number. The key here was to take this three-part ratio and know the total number of pieces in the ratio. So maybe that's a way to look at it. Instead of 12 parts, 12 pieces. Now on the next problem, you could use the tape diagram because you're looking at a ratio of 180 to 144 to 108. I could use a tape diagram, but the problem will be that I'm going to be testing the number of parts. So are there 8 parts? Are there, 3 plus 2, that's 5, 6. Are there 6 parts? Are there 4 plus 3 plus 2? Are there 9 parts? I don't know. The way I would solve this is I would just start dividing by factors that every number shares. So I can tell they're all even. If I divide by 2, I'm finding I've got an equivalent ratio. Let's see, 144 divided by 2 is 72. We've got an equivalent ratio here. Let's see, 108 divided by 2, that's going to be 54. And I'll divide by more factors that they share. 90, 72, and 54. That's even again, so I can divide by 2. I'm going to divide by small factors that they all share, common factor that they all share, until I get to the smallest possible ratio, and it will be one of these.